is AP Calculus AB, section 2.1, page 1. Alright, let's start off first. We're going to graph f of x is x squared minus 4x plus 3 over x minus 3 on your calculator in the standard viewing window, negative 10 to 10 in both directions, the x direction and the y direction. I've done that for us already. Here's the equation. Window, negative 10, 10, negative 10, 10. Graph this, and we see a line, what looks to be a line here. Let's go ahead and sketch that graph into your notes. And we see what looks to be a line. Alright, now how might this equation come up to be this line is if we look at this function that can factor into x minus 3 times x minus 1 all over x minus 3, and we see those x minus 3's then divide out, and we're left with f of x equals x minus 1. And that makes sense then to see this line. We do see a y-intercept here at negative 1 and a slope of 1. Nice. Now, what happens to this graph if we change the window to be negative 9.4 to 9.4? If you happen to have the TI-84 Silver Plus, this thicker one, then that window is valid. If you happen to have one of the really thin graphing calculators, the color ones, the what is it, CE up here, then try negative 9.9 to positive 9.9. It has to do with the number of pixels, little squares that turn on and off when we graph up here as to which window you should use. And they change that a little bit from one calculator to another. Alright, but let's change this window, negative 9.4 to 9.4 in my calculator, 9.9 to 9.9 if you have one of the thinner ones, and graph. Oh, we see something different here. You might have to look very closely on your calculator. You should see a little hole sitting right in there. It looks like this line skipped over one of those little pixels. If I go ahead and change this window to just half of what it was for the x's, so let's go negative 4.7 to 4.7. Now it might be a little bit easier for you to see when I've made this just a little bit bigger, and there is a hole here at that point, 3, 2. When we put that graph in here, there's a hole in here, and that hole is at the point 3, 2. Sorry there, my phone was going off and I had to go shut it off. I didn't want to re-video, so you're just going to have dead space there for a couple minutes. Sorry. Alright, we're going to use table now to investigate to what happens to f of x as x gets closer to 3. So to do that table, let's go to table set. And the table start in delta table doesn't matter for right now, because I want you to change this independent variable over to ask and leave the dependent on auto. Now when you go to table, it should be blank. What this allows you to do is to put in some x values, your own x values that you want, and then your calculator will automatically pop up the y values. So let's find out what happens as x gets close to 3. Let's try 2.9, that's pretty close to 3. Y is 1.9. What about 2.99? A little bit closer to 3. y is 1.99. Let's go one more. And even again. Oh, look at that. Oh, it said I typed in 3, but I didn't type in 3. If you arrow back up on top of that, you can see that what I typed in actually was 2.99999. And over here, the y value that we get out isn't 2. It is 1.99. It's 5 nines in there. And the reason that that showed that up is there's not enough space for the calculator to write all those nines. So it does round it off in the table, but when you arrow on top of that actual value, you do see the actual numeric value. Now, hopefully you can see as x is getting closer to 3, your y values are getting closer to 2. So investigate what happens to f of x as x gets closer to 3. As x gets closer to 3, the y values get close to 2. This concept of what happens to the y values as the x values get close to something answers a question. And what this limit does, it says what happens to the function, the y values as the x values approach a given number. So when we say limit of a function, we're talking about what happens to the function values, the y's, as the x values approach a given number. The notation that we use for this limit looks like this. Lim, so abbreviation for limit. Underneath we'll put as x approaches that particular number a of f of x. The way that we read this is we will say the limit of f of x as x approaches a. Or you can reverse a few of the words and say the limit as x approaches a of f of x. Either one. As we look to this top example back up here, so from this example above, we would say the limit as x approaches 3 of that particular function, that limit is 2. So as the x values got close to 3, the y values got close to 2. It is not saying at x is 3, y is 2. That's not what it's saying. It's saying as x gets close to 3, y gets close to 2. Okay, now we do have some basic ideas about limits. For a constant function, and sometimes it helps to look at a graph. So this c is a constant, and it's telling you to graph the function y equals c. It's a horizontal line at some height of c. As x approaches some number a, what are the y values doing? those y values are staying at that constant. So we have this. The limit as x approaches a of a constant is that constant. The identity function, y f of x equals x, let's find the limit of that function then. If we sketch a graph, of y equals x, that looks something like that. There are some points on here, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, etc. What happens is we look close to some random point, A. That point right there would then be A comma A. So as x gets close to A, the y values get close to A. So we have the limit as x approaches A of x, of this identity function, is A. Okay? All right, now additionally, limits can be separated over addition, subtraction, multiplication, and division. I know that doesn't mean very much right now. Please join me on page 2 and we'll talk about what that means and we'll do some examples. Thank you.